Hey there guys, welcome to part 3 of differentiating polynomial functions. Today we are kicking off where we left off last time with the function x cubed minus x. It's been about 2 months since I've actually filmed the first and second part, so I'm sort of trying to remember the examples at this point, but they're pretty straightforward for someone who's done calculus for a few years, so trust me on this one. So we've got f of x is equal to x cubed minus x here on Desmos at the moment, and we have the critical point minus 1 over square root 3 and 1 over square root 3. I've put these into a little element of tables, so table of elements I should say, and we can draw the functions at both these points using the same function. Instead of having fa, fb, you can put them as a little list and it filters through it and pops them out. So I said to you, we have some critical points at these points here. And we can see it intersects at these 2 points. And the idea of a critical point is when the gradient is equal to 0. And this is what it looks like. Let me take away these points. Just keep an eye on where they were intersecting. And you can see we've got these 2 lines that are horizontal to the x-axis. Now, clearly, we can see that these 2 critical points are different to one another. So if I take those away, the tangent lines, we call them, we can see that this one is a so-called local maximum, and this one is a local minimum. Now, we call these local maximum and local minimum because obviously there's values over here that is greater than this local maximum. If it was the maximum of the entire function, that would be what is called an absolute maximum. And if this was absolute minimum, that would be what we call an absolute minimum. And if it was both a local minimum and a local maximum, then it's still a relative maximum and minimum if that is the absolute maximum and minimum. So that's what we call the maximum, and that's the minimum. And there are some tests that we can look at to identify these if we have a function we're not sure about, but we will go on to that in the next part of the series where we look at identifying critical points. But for now, let's go back and do some more examples. Okay, so now let's consider the function f of x is equal to 3x squared plus bx plus 2. If there is a critical point at the point x is equal to 1, then find the value of b. So how do we go about finding the value of b? Well, we know the critical point is at 1, so we can use our derivative and the fact there's a critical point to find the value of b and hence find the function. So let's go ahead and do that. So we know how to take the derivative using the power rule, so let's go ahead and do that. F prime of x is equal to 6x plus b, where b is some real number. And now we can go ahead and find the critical point. So we know that there's a critical point at x is equal to 1. So a critical point, recall, that means that f prime of x is equal to 0. And we know what point this is happening at. So we can say that f prime of 1 is equal to 0. So now we can plug in those facts and we can get 6 plus b is equal to 0. And therefore, b is equal to minus 6. And we can conclude that the function f of x is equal to 3x squared plus minus 6x, so that's the same as minus 6x, plus 2 has a critical point. A critical point. Critical point at x is equal to 1 with a value of 3 minus 6 plus 2, that is minus 1. So 1 minus 1. And in the next video, we will be looking at determining what type of critical point this is. Is it a maximum or a minimum?